Hello, welcome to this Tetris Publishing video on querying SQL Server. I'm Adam, and in this session I want to show you how to aggregate data in SQL Server. In this video we'll be looking at 5 aspects of aggregating data in SQL queries. The first one is how to calculate totals. Then we'll look at how to calculate totals for multiple elements in a query, not just the grand total, but individual totals. We'll then move on to looking at what the key aggregation functions are in SQL Server. These will extend your knowledge by bringing in functions like averages, maxima, minima, beyond just simple totals. Then I want to look at how you filter using aggregation functions in SQL. Finally, I want to see how you can use aggregation functions to filter your data. To begin this session, let's look at something really quite simple. How to calculate a grand total from a column of figures in a database. So here we are once again in SQL Server Management Studio. The first thing to do is to open a new query window, so I'll do that. And then I'm going to make sure that this query window is connected to the Prestige Cars database. Now I'm going to paste in this first aggregation query and then I'm going to run it. It gives a single figure as a result. That's what I expect. The idea behind this query is to show the grand total for the purchase cost of all vehicles ever bought by Prestige Cars. It certainly seems to have done that. So what makes this query different? Well, firstly we've applied a SQL Server function in the select clause of the query. SQL Server includes dozens of built-in functions that can be applied to SQL to modify the output from a query. Nearly all functions are applied to a field, as is the case here, where the sum function is applied to the cost field of the stock table. In practice, applying a function means adding the function name followed immediately by a left bracket and the field that you want to apply the function to. You then end the function by adding a right bracket. Finally, I added an alias to this particular function because otherwise SQL Server wouldn't add a title to the output column. And you can see this if I select and remove the alias and rerun the query. So what we have done here is to ask SQL Server for the sum or total of the cost column in the stock table. And instead of seeing every record in this table, we see the total cost instead. So now we've seen how easy it is to calculate a grand total from a table, let's take this one step further and look at how to find the total purchase cost for each model of vehicle ever bought. First, I'm going to remove the existing SQL from the query window, and then I'm going to paste in a new query. And of course, I'm going to run the query. The first thing to do is to look at the results. Then we'll take a closer look at the query that actually produced these results. Let's scroll down through the output. As you can see, this query has isolated every model of car in the database and returned not each record, but a single record for each model, with the total purchase cost for that model. Now let's look at the query. In this query I joined the model and stock tables so that you could see the model name and not just a code, and output the model name and the total cost. Then I added a new keyword, group by, to the end of the SQL statement. Simply adding another field that is not being aggregated, usually a text field, to the group by clause is enough for SQL Server to calculate the total for each individual element in the non-aggregated field. That's the model name field in this example. Now, while it's not strictly necessary most of the time to add the field that you're grouping to the select statement, it's normal to do this because this way you can see which figure corresponds to which aggregated element in the query. Aggregating data doesn't limit you to just providing grand totals. There are several other aggregation functions that are available in SQL Server. So, firstly, I'm going to close this query window and open a new one. And then I'm going to paste in a new query. This query will give us the maximum sale price, minimum sale price, average sale price, and number of cars sold for each model of car. I suspect once again that it's easier to understand what the query is doing if we actually run it first and then look at the results. This will help us better understand the code. So let's look at the output and see what information has been returned. As I scroll down the output, you can see that we do indeed have the maximum sale price, minimum sale price, average sale price and number of cars sold for each model of car in the result set. So let's look at the query itself now. As is the case with most queries, we first need to ensure that all the tables that either contain the data we need or that enable us to join the tables containing the data we need are correctly present in the from clause. This query does that by joining the make, model, stock and sales tables. Then the select clause introduces the max, min, avg and count aggregation functions. All of these are applied to the sales price field, and they return respectively the maximum sale price, minimum sale price, average sale price and number of cars sold. And as was the case with the sum function, each of these functions wraps around a field name, which must be a numeric field in the case of the min, max and avg functions. Once again, each field is given an alias for the output. Finally, group by adds the model name field to guarantee that the output will be aggregated for each model of car sold. I now want to move on to showing you how to use aggregated values to filter data in a query. So I'm going to close this query window and open another one. And then, perhaps inevitably, I'm going to paste in the new query. What this query will want to do is to find any countries where more than 50 cars have been sold. But if you think about it, this means calculating an aggregated value and using this calculated metric to filter the dataset. Let's see how this query does this before we actually run it. Because filtering on an aggregated value means applying a new filter technique. Instead of the where clause, which can only filter on an element in a column and not on an aggregated value, I'm introducing something new, the having clause. A having clause lets you filter data on an aggregated value. The having clause only allows aggregated output into the result set where there are more than 50 source records, that is sales, in the aggregate source set in this query. Put another way, it counts the number of sales, identified by the sales ID of each individual sale, for each element in the group by clause, the country, and then only returns the rows where the country that you've grouped on has more than 50 sales. It does this by using the count function applied to the sales ID field and then says where this aggregation is greater than 50. The query is deceptively simple, but it's worth having a look at the 4 elements that it contains, as all 4 are required for it to work correctly. First, the select clause defines the fields that you want to return from the data. Any fields used must either be used in an aggregation function or appear in the group by clause. The from clause defines the source data. In this case, it's the sales by country view that joins most of the core tables in the database. The group by clause then defines any data that you will be aggregating by. In this example, it means repeating the country name field that also appears in the select clause. And finally, you add the having clause that filters on an aggregated value. It's also important to note that the order of these 4 clauses is important. When you are filtering on an aggregate value, you need to place the group by clause after the from clause and end with the having clause. I'm now going to execute the query and show you the results. There are only 2 countries in the output, but both of these countries match the criteria that we have set in the having clause. In previous videos, you saw some of the techniques that you can apply to filter data. Well, you can apply these standard techniques to aggregate queries too. For instance, suppose I want to find any country where more than 10 red cars have been sold. I can make a couple of changes to the current query to do this. Firstly, I'm going to add a where clause to the query. This clause has to be placed after the from clause and before the group by clause. I'll set this to filter on red cars only. Now I'm going to change the having clause to set the number of vehicles to 10, because I'm not sure we sold as many as 50 cars to any single country. And now I'm going to run the query. As you can see, a completely different result is now returned because the query is, in effect, applying two filters: a standard where clause to filter on a single element in a record, and an aggregate query across filtered data. The net result is to show only countries where there are more than 10 red cars sold. To finish this session, let's look at sorting data by aggregated values. Once again, I'm going to close the query window and open another one. Then I'm going to paste in a new query that wants to find the total sale price by make and output this in descending order of sale value. Here's the query. This query joins all the tables that are needed to ensure that we can access the make name and sale price fields. The sale price field is enclosed in the sum function to ensure that the total value is returned. Then the query adds a group by clause with the make name field, as we want to see the total for each make, and the make name field is used in the select clause, so it has to be repeated in the group by. Finally, the query contains an order by clause. However, as we're sorting data on the aggregated value, we need to use the same function in the order by clause that we used in the select clause. I'll now run the query. You can see that the output is ordered, as we required, by the sale price in descending order. Let's look at the main points to take away from this session. Firstly, aggregation functions calculate totals, averages, maximums, minimums, and can also count the number of elements. Then, grouping by an element aggregates each field in the group by clause. If you want to filter on an aggregate value, you do this by applying a having clause, which allows you to filter once an aggregation has been applied. This doesn't mean that you can't use a where clause as well, though. Finally, if you wish to sort data using an aggregation function, you have to repeat the aggregation function in the order by clause. Now, there are a few tricks and traps you need to be aware of when applying aggregation functions. Firstly, if there's any field that's not actually wrapped in an aggregation function in the select clause, then you must repeat this field in the group by clause, or the query will fail. Then you need to remember that the group by clause follows the from clause in a query. You need to be aware as well that when you're using aggregation functions, it really helps to add aliases in the select clause, otherwise you won't see which column you're aggregating. But conversely, when you're using aggregation functions in the order by clause, you don't need an alias, and if you do try and add one, this too can cause the query to fail. Thank you for watching. I hope that you enjoyed this short session and that it will encourage you to continue learning all about querying SQL Server. And remember, if you need a full and progressive introduction to querying SQL Server, you can always take a look at our books on this subject. These 2 volumes can help transform you from a SQL novice to an analytics maestro. To find them, just go to Amazon.com and search for Query Answers with SQL Server. Alternatively, visit your local bookstore. If you want to download the sample data that you saw in this video, as well as the SQL queries that we used, then navigate to www.tetraspublishing.com/SQL Server. Here you can find the sample data for download and practice querying it using SQL Server.